So today I will present my paper, WiBeacon, expanding BLE location-based service with Wi-Fi. So this is joint work with my previous colleague, Zhimen Wenchao, and my advisor, Tian He. Oh, sorry. So Bluetooth Low Energy technology has been very popular in providing location-based service. One of the killer application was iBeacons, proposed by Apple a few years ago to provide proximity detection. For example, you can check into restaurant by detect you are approaching to that restaurant. And it's also used for geofencing, advertising, and many different applications. And people further use Bluetooth technology to do indoor localization and navigation to accurately pinpoint your position in the map. But there's a problem for Bluetooth localization. Specifically, we need to deploy actual Bluetooth infrastructure to enable this service. And these are very small battery-powered beacon devices. So when they are deployed in a large scale, it will become very hard to maintain. So this is an example of my group a few years ago. They tried to deploy 10,000 beacons in Shanghai in order to enable location service for local food delivery service. So you can see from the first day of operation, the number of beacons has been gradually decreased because of many reasons. For example, sometimes the restaurant is renovated and sometimes there's a hardware error. So, and then it is followed by a big decrease in November because the battery runs out. So maintain a lot of beacon become a very big problem for the service provider. And since this beacon does not always has an internet connection, so people have to go on site to replace this beacon. So our basic idea is that can we reuse some existing wireless infrastructure for Wi-Fi to provide the emerging Bluetooth location service. The benefits is very clear. We have already deployed a lot of Wi-Fi infrastructures. There's over 5 million public Wi-Fi worldwide. And also there's some company like Xfinity, they have very good maintenance platform to monitor and manage all the Wi-Fi devices. So the industry has a similar idea. So they use more straightforward way. For example, Cisco, they have those combo devices in which Wi-Fi AP are integrated with Bluetooth hardware to provide a beacon function. But the problem is that you need a new device, new Wi-Fi devices, and still cost actual hardware. So our proposal, a WiBeacon, on the contrary, is a purely software-based solution. So there's 3 key features. So first one, compared to the hardware solution, we only need a software update on those existing Wi-Fi access points. And then it can provide Bluetooth location service. So it does not cost any actual hardware expense. And secondly, WiBeacon is fully compatible with Bluetooth location protocol. So we don't need to have any modification at those Bluetooth mobile devices. So because there are so many different mobile devices, we cannot ask each of them to make the modification. And finally, our WiBeacon is also compatible with the Wi-Fi service on the Wi-Fi AP. So it will not disrupt the Wi-Fi traffic. So after the short introduction, let's go to some technical myths. So technically, this is challenging because Wi-Fi and Bluetooth are designed for different purpose. So in the physical layer, MAC layer, all layer, they are designed in a different way. For example, Wi-Fi, initially they are using DSS, CCK, and OFDM to provide a very high-speed data communication. In contrast, Bluetooth, they use GFSK to provide a very robust and low-power communication. So Wi-Fi and Bluetooth are just like chicken and duck who speak in different languages. So the common belief was that since they are speaking different languages, they won't be able to understand each other. But we think that this is not completely true because Wi-Fi has a much more powerful radio than Bluetooth. So in terms of speed, so legacy Wi-Fi protocols has already been 11 times faster than Bluetooth. The second observation is that Wi-Fi has more sophisticated vocabulary than Bluetooth. So, Bluetooth I just use very simple modulation, like phase shift to modulate 0 and 1. A positive phase shift means 0 and a negative phase shift means 1. In contrast, Wi-Fi can create a lot of different phases. For example, the most basic Wi-Fi modulation, QPSK, can already make 4 different kinds of phases. So if we carefully choose the Wi-Fi data over time, we can actually create positive and negative phase shift that Bluetooth can understand. In other words, Bluetooth is really a duck. Like it can really produce really simple and long sentence. And Wi-Fi is more like human beings. We can speak really fast, and we have a really complicated vocabulary. So technically, we believe that since human can mimic how duck work, it's also possible for Wi-Fi to mimic how Bluetooth transmit. So the idea is called signal emulation. So we are sending a standard Wi-Fi packet with carefully selected payload. And this payload in the physical layer, when they modulate into wireless signal, the signal will be similar to a Bluetooth signal. We call the emulated Bluetooth signal. And this, when the signal is received by a Bluetooth receiver, it will be detected and demodulated in the same way as a standard Bluetooth frame. Yeah, more specifically, what we can do is that giving me a targeted Bluetooth data, and then we try to figure out what vocabulary in Wi-Fi dictionary we should use to approximate it. And then since Wi-Fi is 11 times faster, we can just repeat sending that vocabulary 11 times, and it will produce exactly the same waveform as we have for Bluetooth. So this looks really simple. But the problem is that Wi-Fi cannot transmit arbitrary, string of vocabulary. So what happens is that when we are transmitting any data in Wi-Fi, we can control the data in the payload, and then the payload will go into the hardware, and the hardware will augment this payload into code words, and the code words will be modulated into the signal. So due to this encoding, the produced waveform will always be imperfect compared to the standard Bluetooth waveform. And because these codes are predefined, we cannot do any modification in the Wi-Fi hardware. So our idea is that since we cannot do anything in the Wi-Fi side, how about we do something actually leverage something in the Bluetooth receiver side. And what we do is that we carefully look at the Bluetooth hardware, and we see there's in every Bluetooth devices, there's a low pass filter in the radio front end. Basically, when it receives a wideband signal, it will cut the signal into 1 megahertz narrow band. And only a narrow band signal will actually go to a demodulator and decode it into bits. So from signal processing theory, low pass filter can smooth out spikes in the signal. So if you have some spiky errors in the signal, a low pass filter can always get rid of them. So the critical design is that we carefully choose the Wi-Fi code word with unique error pattern. So we want to choose those Wi-Fi code words that produce scattered imperfection. So those errors are far away from each other, so that the low pass filter can get rid of them. We want to avoid choose those errors that are concentrated with each other, because after the low pass filter, those errors will still exist. So WiBeacon have to address other problems due to the compatibility issue between Wi-Fi and Bluetooth. For example, Wi-Fi usually just serve one channel, while Bluetooth, it do channel hopping around a lot of different channels. Also, Wi-Fi and Bluetooth, they are using a lot of different central frequencies. So there will be some misalignment that need to be compensated. So please refer my paper for more detail for this design, and we will go to the evaluation. So we implement this WiBeacon technology on OpenWRT, and we test it against a chipset from different vendors, including Qualcomm, Broadcom, and MediaTek. And we find that WiBeacons work well on all these Wi-Fi chipsets. So this is generically applicable on almost all the Wi-Fi devices. So in terms of performance, WiBeacons has achieved full compatibility with both Bluetooth location service and the Wi-Fi. So for Bluetooth, you can see the frame error rate in the same received signal power are exactly the same as a standard Wi-Fi beacon. So in other words, we are as robust as a standard Bluetooth communication. Also, WiBeacon is fully compatible with Wi-Fi services. So you can see when WiBeacon is working, we can still do video streamings. And we also examine that this kind of beacon activities will only reduce the bandwidth by 8 megabps. So one of the highlights is that we deploy this WiBeacon in some real-world applications. So this is before pandemic. We collaborate with some food delivery company in Shanghai and deploy some beacons for them to do location-based service. So basically what they want to do is that they want to have their food courier check in at the restaurant, and the company want to know when they arrive and when they leave. So they need to deploy a lot of beacons in a lot of restaurants. But luckily, all restaurants has already deployed, Wi-Fi access point for providing free Wi-Fi to customers. So it's possible to reuse some of the Wi-Fi AP to serve this Bluetooth location service. And this gives me an opportunity to examine the compatibility of WiBeacons with a lot of different Bluetooth devices, because those food carriers, they can carry all kinds of smartphones and mobile devices. And it turns out that WiBeacons are compatible with all the 150 different kinds of smartphones that are used by those couriers. So I think it's a good time to show a live demo of WiBeacons. Second. you see the screen? No. Maybe just
stand it. Are you going back to the PowerPoint?
Oh yeah. Oh, see.
See it over here.
Oh. New share.
It's not the share. New share. That one, right?
Okay, yeah. Oh, maybe share this screen. No.
You'll have to look on the side.
Okay. Okay, so I have a live demo. So this is the phone that's scanning for the WiBeacons. And although you can't see, I will. My mouse. I will start a WiBeacon.
Start on share your screen.
Oh, resume.
Anybody has question, you can start lining up.
Yeah. Okay. Oh, still connected.
I don't think this screen you're changing is actually showing.
Okay, it's good. No problem. Okay, so I will. So now I start the beacon service, and it actually transmits the Wi-Fi signal from this Wi-Fi AP. And you can see the screen in screen. This Bluetooth scanner actually can capture those Wi-Fi beacon signal. So it is robust, very robust, and we believe that it can be used for product purpose. Okay, so we can skip the video since the live demo works. So I want to wrap up this talk with a brief retrospect of this technology. So I talked to some of the young researchers yesterday, and some of you are really interested in this idea. And some of you told me that there seems to be a lot to be done. And this idea has existed for quite a long time, 30 years. Yeah. So the first idea was of the cross-technology communication actually started in MobiCom 2009. So I was still in high school in that time. So at that time, this is CTC in really low speed using packet level information. For example, I transmit a long packet, that means 1, and short packet means 0. So really low speed communication. And then in 2015, there's another breakthrough called 3B, also in MobiCom. So MobiCom people has making a lot of contribution to this, this CTC, study. And the true breakthrough happened in 2017 when we enable physical layer CTC, meaning that different wireless technology, they can communicate with each other using standard communication. So Wi-Fi can transmit Bluetooth packet, and Bluetooth packet somehow can transmit to Wi-Fi in a standard way. And last year, 2021, we pushed the limit of this CTC to approximate the standard communication. And I want to say, in 2016, we actually have 3 branches of researchers. WiBeacon follow the first branch is called the downlink CTC. from some high-end devices like Wi-Fi to Bluetooth. And then there's a different branches start from then, which is try to send the data from low-end devices back to Wi-Fi. And then there's also a lot of different CTC-based applications. Yeah, so the last slide, we can see this different speed. In the downlink side, we already approximate the standard communication. Uplink side, we improve a lot, but there's still a lot of gaps. So to summarize, in downlink side, I think probably we have already have a very mature solutions. In the uplink side, we still lack a solution that can currently achieve high speed, reliability, and generality among different devices at the same time. So probably there's some fundamental limitation that need to be conquered. And what's most interesting in future direction, I think, is CTC application. For example, localization of WiBeacon is an example. And I think there's a lot of other applications to be explored in the future. And that's it.
Hi, this is Heike from Georgia Tech. So my first question is, do you inject specialized frames for the WiBeacon, or is it possible to incorporate it into like the existing Wi-Fi beaconing mechanism?
Oh, yeah, that's a very cool question. Yeah. So the question is that do we need to send the extra packet in order to do this beaconing, or we can reuse the existing Wi-Fi beacon to do that? I think that's a really good question, very good questions. So I think we can use the standard Wi-Fi beacons, because the Wi-Fi beacon actually allow people to define some vendor-specific message after the standard message, and we can reuse that in order to do these applications. One of the problems is that the Bluetooth is really slow, so the packet is very long. So it makes the Wi-Fi beacon very long, and all the Wi-Fi devices need to accept this Wi-Fi beacon. So it will cause overhead to all the Wi-Fi clients, and we don't want that. So in our implementation, we actually transmit this packet in a probe frame. So probe frame is also a Wi-Fi management frame that Wi-Fi devices will send into other Wi-Fi. Yeah, less infrequent, and Wi-Fi devices does not receive that package. So yeah, I think that answers your question.
Thank you. And my second question is, what version of Wi-Fi are you using, or is it compatible with multiple versions?
So the question is, what kind of Wi-Fi devices we are using? Yeah, so we are currently using a commodity Wi-Fi router. So one of the questions people always ask is which standard of Wi-Fi we are using. So in this project, we are actually using the legacy Wi-Fi 11B standard, a very old standard. But luckily, all the Wi-Fi access points need to be backwards compatible. So even the most advanced Wi-Fi 6 router, they still support 11B. So all the Wi-Fi devices can support this. All the Wi-Fi AP, can support this. And I think there's also a lot of Wi-Fi device like client, for example, the surveillance cameras, Wi-Fi light bulb. I believe that they can also support that, because we only need some modification to the payload, and every type Wi-Fi client has such capabilities.
Thank you.
Cool. Let's thank the presenter again. Cool.